Hey folks, we got another set of video notes today, and they should be relatively easy compared to the stuff that we've been doing. But we need to talk about what heating and cooling curves are and what they mean for us. So if you recall, there are three states of matter on Earth, these solids, liquids, and gases. But we have phase changes that can bring us from one to the other. So we have different names for that, like when you go from a solid to a liquid, it's melting, or liquid to solid is freezing. If we go from a liquid to a gas, it's vaporization. From a gas to a liquid, it's condensation. And we can go from a solid straight to a gas, which is sublimation, or vice versa, which is deposition. But each one of those states, they're determined by how close those particles are holding together, the attractive forces between the particles that hold them together, and how much kinetic energy those particles have to maybe overcome that attractive force, which we'll see in a second. If you remember, temperature is a quantitative measurement of thermal energy. It gives a number to how much kinetic energy those particles have. And when we increase the thermal energy, that increases the temperature. When you increase thermal energy, those particles are moving faster too. So eventually, if those particles start to move faster, they can overcome those forces that attract them together, and they can move from a more rigid state of matter to one that allows for more movement, like from a solid to a liquid. Or if we take some of that energy away and we slow down the particles, then the attractive forces will overcome the kinetic energy and they'll stick together better. So we can maybe go from a liquid to a solid. We have these things called heating and cooling curves. Essentially, it just relates our temperature on the y-axis to how much time or the amount of heat there is on the x-axis. And it shows our different states of matter as of a substance as it's being heated or cooled. In this case, we're adding heat energy as we go to the right. And you can see it's a solid down here, and a liquid over here, and a gas up here. Now, what you might find interesting of these horizontal lines in the middle, where it says melting and freezing and boiling and condensation, we'll get to what that means in a second. This is kind of the same idea. The temperature goes up here, the heat energy goes up here. We have a line that has a slope where the solids are here, then it hits this point where it levels off for a little while. And that's the transition between a solid and a liquid, whether it's freezing or it's melting. And then it's a liquid for a while, and we can warm that liquid up until it starts boiling. And from the time that it starts boiling to the time where all of it is a gas, it's this certain space right here, and then all of it's a gas, and we can heat up the gas or cool it and go back the other way. This graph kind of helps out a little bit too to think about it. Enthalpy is another word for heat energy. So by adding more heat or thermal energy, we get to our different stages or our different phases, states of matter. You notice here, according to this graph, gas has the most enthalpy or heat, which means it has the most thermal energy, which means those particles are moving the fastest and they're not close together anymore. Then we can go down a little bit. A liquid has a medium amount of thermal energy, and then solids have the least amount. So reading a heating or cooling curve is fairly simple. This one's a more, a less illustrated version of one. But you'll see down here, you start out, maybe this is water, and we start out as a solid at negative 40 degrees Celsius, and we warm it up until it starts to melt. And between the time that it starts to melt and the time where it's completely a liquid, it's at this certain temperature right here. The whole concoction is 0 degrees Celsius. The whole time it's melting until it's a liquid. And then we heat up that liquid, and we keep heating it up, all the way till it gets to 100 degrees Celsius. And at that point, some of it starts to boil. All the way from here to here until it's completely boiled off, it's exactly 100 degrees. Some of it will be water, some of it will be gas, but it's all 100 degrees until it all turns to gas, then we can heat it up from there. You will need to know how to draw one of these It's pretty simple. You should see that it just has a sloped line here. It levels off at 0, sloped line here, levels off at 100, and then another sloped line that goes from a solid to liquid to a gas. It's very easy to do for water. Other substances work pretty much the same way, but they might have different shapes to the curves. I think that's about it. So on your notes worksheets today, you have just some questions about everything I just said, plus a couple practice problems to get us ready for the lab tomorrow.